Hi there, in this video, I will introduce Factory I/O software, which can help us in this tutorial, to test and learn PLC programming. First, I will introduce my system connections. Maybe it can help you, when you're using several systems, like me. Then, I will design a simple project in Factory I/O, and also, I will explain how this software can connect to my controller, using a LAN cable. Finally, I will test a simple project using my PLC and Factory I/O. Before we get started with today's video, I just wanted to inform you about all the great content I have been releasing on the PLC Goods YouTube channel, which includes industrial automation PLC programming, HMI and microcontroller-based developments. My name is Syed Reza, and if you enjoy this video, I would appreciate it if you could click the subscribe button as well as the notification bell, to receive the latest and the greatest content I will be posting through the channel. Well, as you know, I'm using Logix 5562 processor of Allen Bradley controllers in this tutorial. Also, I'm using two laptops. Until now, I have explained how my PLC can be programmed, using RSLogix 5000 and RSLogix softwares. In this video, I'm going to introduce and use Factory I/O software. I have this software on the next laptop. I will explain how this software can be connected to my controller via the Ethernet module. Also, during this tutorial, sometimes, I need to transfer data between the two laptops, using remote desktop ability. You can learn this ability of Windows on the internet. That's simple. Here, I have is a simple problem. I have only one Ethernet port on each device. For example, if I need to connect the PLC to the RSLogix 5000 on the first laptop, I won't able to connect my controller to Factory I/O on the second laptop at the same time. To solve this problem, I can use a simple modem or router. I just need to connect each device to a port of modem, without any special settings. Now, each device access to other devices. As you know, the main point in a network is assigning a different IP address to each device. Alright, in the previous video, we have written and tested this program, to turn on off an output, using two digital inputs. Now, let me open Factory I/O software. Let me create a new project. Now let's insert a simple conveyor which uses a motor. An emitter places boxes on the conveyor. To give height to the added equipment, just press the V key on your computer keyboard. Now, let's have a simple control box, with two start and stop push buttons. Alright, in this video, I want to use these two push buttons to turn on the conveyor, using the previous PLC program. Naturally, the Factory I/O cannot change the voltage state which has been appeared on a real digital input, but it can change the controller memory. I need to define some tags in the controller, and use the defined tags for this or another contact. So, right-click on Controller Tags, and select New Tag. Here, I write the new tag name, Factory I/O. Because I want to change this tag, inside Factory I/O software. Instead of using a double integer format which has 32 bits, let me use integer format for this tag. So, the defined tag will have 16 bits. Double-click on Controller Tags. Now, I have two types of tags. The first type is started with local. These tags refer to the real input-output modules. I've used 2 digital inputs and 1 digital output in the previous video. But this tag, factory IO, which has been created just now, is an internal tag, on the controller memory. As you see, this tag has 16 bits. I want to use 2 bits of this tag to turn on off the output. Like 2 digital inputs, which have been used before. Let's back to the PLC program, and modify it. Like this digital input address, I want to turn off the output from the factory IO software. So, let me insert another normally close contact. Here, I use the first bit of the factory IO tag. Similarly, let me use the next bit of the internal controller memory, factory IO tag, to turn on the output. I need to insert a branch and a normally open contact. Well, let me compile the program, to ensure there isn't any error. If you remember, I have selected my Ethernet module connection, as the default connection. So, instead of going to communication and click on Who Active, I can download my program, from here. Well, my controller is in run mode, I must change it to program mode, with its mini switch. Well, let's back to run mode. Now, based on the program, I can use 2 added internal memory, to turn the output on or off. To change each bit of memory, I can right-click on the bit memory, and select Toggle Bit. But, let me show you, how the factory IO software can connect to my controller, and change its internal tags. The first step is to connect the factory IO software to my controller. So, let's go to the File menu and select Drivers. From the top menu, I must select the controller type. This software supports CPUs, which have an Ethernet port, otherwise, you must buy and install an Ethernet module beside your CPU, like me. Here, I select Allen Bradley Logix 5000. Now, in the configuration section, here, I must write the IP address of my Ethernet module. If you remember from the previous video, it was 192.168.1.13. Here, I must write my CPU slot number. Then, I must determine my controller tags. These tags will connect to the equipment, like the conveyor and push buttons, which have been inserted in the factory IO. The first row is bool inputs. As I mentioned before, factory IO software unable to change the appeared voltage at the real digital inputs, so, we have defined the factory IO tag. We have used 2 first bits of this internal tag, as the second stop and start contacts. Also, I will use this tag of my real digital output, local30.data. Factory IO software can read and use the state of digital output addresses. So, in the prefix column, I write the first part of selected tags. Let's don't change offset values. In the count column, I write number 4. So, I will able to use 4 first bit of the selected tag, but as you know, I only need the first and second bits. Similarly, in the second row, I write my digital output address. In this project, we did not use integer or floating point data, either as input or output. So, I write 0 in their count column. As you see, here, I have a processor with this IP address. Also, the first 4 bits of the selected tags are accessible, I can use them in factory I/O software. Let's connect this software to my processor. Now, I can easily connect the inserted equipment in the factory I/O to my processor. Alright, in the previous video, we have used 2 real push buttons to turn a signal lamp on or off. In this project, I want to use 2 virtual push buttons to turn the belt conveyor on or off, using factory I/O software. Let's back to the designed factory I/O. Pay attention, if you click here, you will able to see each name of inserted sensors or push buttons. And if you click here, you will see each name of devices like motors and belt conveyor. Now, let's start the simulation. Let me have a better view of my PLC, its program, and factory I/O software. Well, in the PLC program, I have used 2 push buttons to turn on the output. And also 2 push buttons to turn off the output. Pay attention to my program. At the beginning, the first normally close contact pass the virtual power, because its related push button is normally open and don't change the first contact state. But the second one, don't pass the virtual power, because its connected push button is normally close. I will explain this item later. Now, to solve this problem, I have to use a normally open contact, instead of using this normally close contact. So, let me modify the program. As you see, now, the virtual power can reach behind start contacts. First, let me use 2 real push buttons to turn on and off, the signal lamp and the belt conveyor. Similarly, I can use 2 virtual push buttons, to turn on or off the signal lamps and the belt conveyor. Alright, now let me tell you a point of using contacts in your programs. First, see this simple circuit. In this circuit, the status of the lamps depends only on the status of the push buttons. At the beginning, for a normally open push button, the lamp will be off. And if I use a normally close push button, the lamp will be on. But, when we're using a PLC, with this program, we can have 4 states at the beginning. As you see, this program is similar to the right circuit, but the status of the outputs depends on which type of contact and push button are used. For example, let's explain the last state. When a normally close contact is connected to a digital input, which is connected to a normally close push button. In this case, like the industrial circuits, the virtual power reaches this contact. Note that, this push button lets voltage to appear at the digital input. So, PLC changes the state of this contact. And open it. Thus, at the beginning, or normal conditions, the output will be off, because the virtual power won't able to reach the output. Try to understand other states. You will see, if all used push buttons will be open, the PLC program and right circuit will have the same logic. Alright, until now, we have learned how to connect a real PLC via its serial or Ethernet port, create and use a virtual PLC station, or use factory I/O software to test our programs. In the next video, I will introduce another software, Factory Talk. It can be used to design HMI screens, which can be programmed to display important status and information to the operator. HMI is short for Human Machine Interface. After that we'll continue learning RSLogix 5000 software, which is the main software to program my PLC. But, I hope you can test your programs, with the help of at least one of the other software, and follow these educational videos. Thanks for watching my content. If you have any question on this topic, make sure you leave them in the comment section below, and if you can spend a few seconds of your time liking as well as sharing this video, if you enjoyed it, that will mean a lot to me. If you have any suggestions for the channel, such as what kind of hardware or software I should be covering, then make sure to leave that in the comment section. See you next time. Bye bye.